Hello, hi, I'm Aisha Samsudin, and I would be answering the data analyst questions and providing the responding answers. So, first we look at the data analyst concepts and methodologies. So, key topics in this presentation would be data mining, time series, ethics, and modeling. So question one is, what does the CRISP DM methodology for data mining entail, and what does the data analyst do in each step? So CRISP DM stands for Cross Industry Standard Process for the data mining, a framework commonly used in data mining projects. It helps structure the process of transforming data into actionable insights so we can make better decisions. So the first step is of understanding the business. The goal is to align the project's objectives with the business goals. So data analysts would come in, meet with different stakeholders, internal and external, and understand the problem of the business, define the measurable success criteria, translate the business needs into data science questions. So basically, what are we trying to solve, and metrics matter to the business. So the second step is in data understanding. So the goal is to familiarize ourselves with the data, identify inequality issues, and what we really need to address. So the data analyst would collect the initial data from various sources. This can be through databases or APIs. Then examine this data for patterns, trends, and certain issues and see what we really need to focus on. Generate preliminary visualizations like histograms, bar charts, and so on, and also create and form initial hypotheses based on data exploration. Then the third step is data preparation. So the goal is to clean, transform, and structure data for easy analysis. So data analysts would do some data cleaning, removing duplicates, correcting missing values, incorrect errors, and also filling out irrelevant data. And feature engineering, which means creating new features, normalizing data, or also creating categorical variables to make it more suitable. And then data transformation, which is aggregating or restructuring data to match model requirements. And then feature selection is to identify relevant features based on data analysis to reduce certain complexities in models. So the fourth step is modeling. So modeling, the main focus or goal is to use certain selective modeling techniques to uncover insights on predictions. So a data analyst would use model selection, choosing appropriate algorithms on the problem like regression or classification of categorical variables and outcomes, and then using a model training technique. So this is where you split the data set into training and testing sets, and then train the model on the training sets. And then also creating hyperparameter training, so adjusting the model parameters to optimize performance, and also model validation. So then you test the model that you've created and see if it's performing well and if there are any use of validation techniques like cross validation and also holdout tests. The sixth step is deployment. The goal is to put the model into production for the real world application. So now we need to see what we have attained. Is it really applicable in real life? So a data analyst would do model integration, deploying the model in a live environment and seeing if it really works, like dashboards and decision-making systems. Then monitoring this performance, setting up systems to continuously monitor so we receive the accurate feedback that we require. And then reporting this, communicating our insights to various stakeholders, internal and external. So question two is to explain what needs to be done before you can forecast time series. In other words, what does the time series analysis involve? So before forecasting a time series data, we need to focus on certain key steps. The first one is data collection. So we gather historical data at regular intervals, whether it's daily, weekly, or monthly. And then we also do exploration and visualization. So analyze the data to identify trends, patterns, and outliers. Then we do a stationarity check, so ensuring that all the statistical properties are always constant and nothing is changing. And if it is, we make the adjustments like differencing. Then trend and seasonality. identifying and removing trends or seasonal patterns in data. Model selection, always choosing the right forecasting model. So this can depend. It can be either an exponential smoothing or an ARIMA. And then model validation, splitting the data into training and test sets to evaluate the model's accuracy. So the last step is very critical. So in order to ensure that everything works well, we need to focus on step 1 to 5. So question 3 is discussing the main principles of data ethics as well as what companies or organizations could do to uphold these principles. So the main principle of data ethics is to always ensure that transparency is focused on, that we make things very clear right from the beginning based on everything that's collected and used, and provide easy to understand privacy policies and disclosures, and also being very fair, ensuring data practices are unbiased and do not discriminate against any race, ethnicity, or gender. Action, regularity, audit for bias and use diverse data. Accountability, always taking responsibility for data practices and their impact, and also setting up governance and accountability frameworks. 4 is privacy. Protect individuals' personal information, action, implement strong data protection measures, and gain certain informed consent. So, by adhering to all these principles, we can ensure that the ethical use of data is sustained. Question 4 is imagine you're an analyst at a financial services company and you have some concerns about the bias in the way a predictive model was measured. How would you raise your concerns with your manager? And also to make some suggestions on avoiding bias in the future. So, if I was an analyst at a financial services company and had concerns about bias in a predictive model, I would first prepare evidence. I would gather all potential data of model predictions across various demographic groups. 2, I would schedule a meeting. I would want to discuss what's really happening and clear my concerns, yeah, my voice, my opinion, in a very constructive and diplomatic manner. Then I would explain the issue. I would present the most potential impact of bias on a business outcome, customer fairness, and regulatory compliance. Then the last step would be to suggest solutions, focus on proactive ways to address and prevent future bias. So, ways we can avoid bias is by using very fair metrics, like incorporating metrics like demographic parity or equal opportunity to assess bias in model predictions. And also ensuring that we use a diverse set of data and having a larger sample size by using representative and diverse data sets to avoid underrepresentation of any group. Regular audits by continuously monitoring the model and audit for bias after deployment to ensure that everything is super fair. Test across demographics to evaluate model performance across different demographic groups. This approach ensures that the bias concerns are addressed and everything is focused on improvement. So, in question 5 is to explain the difference between regression and classification models in predictive analysis. When would you use one of these models over the other? So, in a predictive analysis, regression and classification are two types of models and are used for different purposes. So, regression models' purpose is to predict a continuous numeric outcome. An example is predicting house prices, temperature. So when to use when the target variable is continuous, any value within a range like income or even stock prices. While classification models, the purpose is to predict a categorical outcome or class label. So example, classifying emails as spam or not spam and predicting customer churn, like for example, a yes or a no answer. And when to use when the target variables are discrete and falls into categories, whether it's like fraud detection or various other sentimental analysis. Key differences in regression and classification is regression is more for a continuous data set. It's always predicting a number, which classification is more for categorical data. Using regression is when you need to predict a numerical value, and classification is when you are working with categories. So, thank you so much for attending my presentation, and I hope you enjoyed. Have a good day.